Hi everyone, my name's Tom, and today I'm going to be giving a talk on NFC Unlocked. So if I can get a quick raise of hands first, who knows what NFC stands for?
No fucking clue.
Good one. All right. And how many people have used NFC in the context of Android development? We've got a few hands. All right, and how many of you use it on a day-to-day basis? Many? Okay. Cool. So a bit about me first. My name is Tom, as I mentioned. I'm a mobile engineer, so I work with native Android and native iOS. And I work for a company called PassEntry. So PassEntry are a mobile wallet provider. Think loyalty passes, membership cards, all that kind of thing in Google Wallet and Apple Wallet. So for the past few months, I was tasked with creating an Android app that can read these passes. So I've learned a lot about NFC in this past couple months, and I thought it was quite fun, so I thought I'd share some of that with you today. So this will be in two main parts. I'll cover the basics at the very start. What is NFC, some of the main use cases and why you'd want to use it. And then we'll cover a basic read and write example. And then in the second half, we'll talk about encryption, get into more fun stuff about like microprocessors, how you can use end-to-end encryption and really get the benefits out of NFC. And finally, we'll be doing reading a bank card and seeing what information we can get just from tapping the phone. All right, so the definition of NFC is two devices talking to each other in shorter than 4 centimeters typically. And this is quite well adopted. So 2 billion devices, every iPhone since the iPhone 6 is pretty much has NFC nowadays, and also pretty much every Android device has. So it's been a quickly evolving space, and quickly evolving as well has been smart cards. So I'm sure a lot of you remember paying with magnetic swipes. These were introduced in the 70s. There's no encryption whatsoever here. So we're talking, you could swipe and you could get literally your name, your account number, all that kind of thing. That was very insecure. We moved on to a bit in the 90s and noughties with a contact card, things like EMV chips and SIM cards. Here it still required contact, but you had benefits like encrypting data, so this couldn't easily be replicated. And now we have NFC. This was more 2015 kind of time. It's a lot more convenient. You don't need to touch it. It has the same encryption as contact cards, but also card tokenization. So things like when you pay with Google Pay and Apple Pay, what it actually does is it creates a token, so it won't give you a real card. It'll create a dynamic card each time you do a transaction. All right, and there's different types of NFC as well. NFC-A is pretty much the one you'll always be using. This is from payments, ticketing, URLs. If you ever go to Japan or Asian countries, you'll also be using NFC-F or Felica. NFC-B, not so commonly used, but I thought I'd mention it. Sometimes like some transport links use it. It's high security, but also it's quite a lot more expensive. And then RFID, I know it's not NFC, but NFC actually evolved from RFID. It's for a lot bigger distances, like 7 meters. So it's only one-way communication, but it's used quite a lot in like factory settings, like for locating crates. Right, so some of the use cases that we can use. Payments, we all use it for things like paying for your groceries, like your physical cards. Access control, so on my wrist right now, how I get into my flat now is NFC. I just scan the door, like you scan a hotel, that's use NFC. Ticketing, entering events, a lot of companies now, because you can simply screenshot a QR code to prevent more fraud. Ticketing's another good example. Item verification, things like clothes, say a lot of the higher designer clothes, nowadays they've got a little chip on your arm. You can scan it and you can tell if it's legitimate or not. Identity management, things like passports. As you go through passport control now, I'm sure at e-gates, you've all noticed you can just tap your passport and it lets you in. This is all done through NFC. And simple data transfer as well. So it was actually, the first use case it was for transferring music. This didn't really pick up, but that was why NFC was first invented. Right, so demo, I'm going to be giving a quick demo on how we can quickly set up a simple read and write example in our NFC. So I made a super basic app. There's no utility to it yet. It's a simple screen. And what we're going to do, we're going to first start from scratch. So what we first want to do is we want to go to manifest and add view permissions. So let me quickly add this to my phone. So here I've got a NFC card, and what we're going to try to do, we're going to add this NFC permission. And in our main activity, all we need to do, we need to add the reader callback. Perfect. And here we want to implement our members. So we want to implement onTag discovered, which is here. So what this does is when the app detected tag, it will run this function. And we also want to start our NFC reader, which is here. So create a private function. Sorry, this isn't ideal. And here, Copilot's done it for us. We've promise it's not cheating, so we need to go to this. But like we mentioned before, we want to use NFC because that's the card type we're using. And this is the rules for what we want to look out for our NFC adapter. So let's add this to our onCreate. And then also we want to write to it. So we're going to write a simple message first, like let's write hello Lundroid. So let's do write NFC. Let's see if Copilot can do it. Nope, not quite. Val. There we go. It's getting the hang of it now. So NDEF stands for NFC Data Exchange Format. And there we go, Copilot did the rest. So what we do, we create the record using non-NFC data exchange formats. This is for all basic NFC transactions, things like writing messages, uploading URLs, that kind of thing. And instead of hello NFC, let's say hello Lundroid. And we also want to log this just so we can see this is done. Let's import log. This is a pretty simple app, but hopefully we should be able to see a log that this works. Oh, it's the curse, the live demo curse. Is there an error somewhere? This is the danger of doing it live. No, one more try. Okay, we're going to skip this, but basically, basically we should have been able to write it, and then a read would simply be, let's see if we can, instead of creating a MIME, we want to say reading to the NFC tag. Instead of we want to do a record, we want to get the record this time. Get record. Sorry, reading. So we get the message and we get the first payload of this. And that's how we would read from it. So why is this useful? I've actually had quite a lot of fun with just this even basic application. So when I was out and about in my favorite tri-space in Acton, Tri-Sport, I noticed there's an NFC tag. It was just a basic one, but what a lot of people forget to do is they forget to lock them. So with this, I decided to overwrite it. And I could have done something a lot more dangerous. I just simply did my company's website. But as you can imagine, you can have a lot of fun with this. You can link it to wherever you want. So yeah, now we'll move on to the more exciting bit, in my opinion, is your device-to-device communication. So what makes NFC really special is the fact that you can have a secure conversation between two devices. You can stop bad actors, and also you can make it so that the same transaction can't be used over and over again. So in this case here, we're going to have a reader. We're going to have a smart card. A reader has a public key and private key, and an NFC antenna. So this public key and private key are used for encryption, and the smart card has a microprocessor. So even though the smart card doesn't have like a battery source, for example, it uses the NFC antenna, which shoots electromagnetic signals, which actually power the microprocessor in order to do these transactions. So the first thing we'd want to do is request data. So the reader will send its public key, it will send a nonce, and it will send any additional information. So the public key is used for encryption. The nonce, so we make sure it's unique, you can't repeat this transaction. And additional information would be like what kind of data you want to specifically receive. And then once smart card's got that, it will encrypt the data using the public key and the smart card's private key. It creates something called a shared secret. So it encrypts this. It will include in this encrypted data requested data, the nonce, and also a timestamp, which is also another way to secure it. And it will send back the public key. So with this public key, the reader can then combine it with its own private key and decrypt it, and then it can return a success or fail. So how is this used in real-world examples? Let's go use an example of contactless payments. So we have a reader and a bank card. First of all, the reader sends the command select payment application list. So this will be, is it an Amex, is it a Visa? It does different operations depending on what type of card it is. So then the card would say, I'm an Amex, and then the reader will say, okay, so select the Amex application. I want the template for the Amex. So it will return this template, which is the response structure. And the third step is get the processing options. So different cards have different risk capabilities as well. So things like offline mode, how much you can send in one transaction, what currencies you support, that kind of thing. So all this information is sent in the third request. Then fourth request is reader records, so reader things like card number, expiration date, cardholder name, that kind of thing, and other details that are needed to secure the transaction. And then finally, using our public keys and private keys, we create a application cryptogram, and this is done to validate the card and transaction, so you can send to your payment service provider. They can confirm it's really you. Awesome. So I'm going to show you how we can do this code as well. It's just going to be a very quick, high-level code because it can get quite deep. But instead of NDEF, use something called ISO, which is basically for more complex NFC transactions. And for this, we're going to use something called an EMV reader. So the EMV reader stands for EuroPay, MasterCard, and Visa. Though other cards have joined more lately. And what this EMV reader does is it's a set of protocols they've created that each bank card can use. So here, like I mentioned before, we've got select payment application list, we've got get payment application, all this kind of thing. So select payment application list, we literally ask for a bytecode of 2PaySys. So 2PaySys is the EMV code for I want to do a contactless transaction. And then with the ISO, we literally transceive this data. And I'm not going to go too into depth on the other ones, but with this, we get an application, and we can see if it's a valid card. If it's a MasterCard, we can check if it's a Amex, if we want to support it, that kind of thing. And each of these is literally in hexadecimal format as well. So we can do this, and with all this information, if the live demo was working, we'd be able to show the card number. But yeah, we also pass terminal information, that kind of thing. So things like transaction amount, what currency you want to use, the nonce, that kind of thing. So yeah, that's how an EMV transaction would work. And I think that's all I had planned today. I did rush through that a bit, but do we have any questions?